Now let's talk about operating on a list. Suppose we have the numbers 10, 20, 30, 40, and 50, and we wanted to add those numbers to get a total. In old school programming, you'd probably do something like this. You'd initialize an accumulator or a return result. Then you'd loop across the list, adding each item into the accumulator. When you finish the loop, you'd return the value as the sum. In Q, we don't do any of that nonsense. In fact, we say, no stinking loops. So let's see what it would actually look like. Going to the console, we have a list 10, 20, 30, 40, and 50. We want to initialize the result at 0, and we want to add across the list. So if we read this, we would say, well, initialize to 0, add across, the slash will read across, the list. And that's all there is to it. Did you see any loops there? No, neither did I. In fact, this is a style of programming called declarative programming. In Q, you say what you want, not how to do it. In traditional programming, you write loops. You write statements to initialize accumulators, to check the end of the loop, to return things. That's how. That's called imperative programming. In Q, we just say what. That's declarative programming. All right? Now, there's various terminologies associated with this. The slash operator is often called over in Q. In functional programming, it's called fold in this particular example. But what it does really is it takes the plus immediately to its left and it converts it into a similar type of operation. Plus operates on two numbers. Now we've got a plus slash that operates across a whole list. It does it pairwise, the accumulator and each item in the list. But it's a new related version of plus that does the same thing on a list instead of on two numbers. Okay, so let's look at this for a second and say, what else could we do with this? Well, sometimes we don't actually need to specify the accumulator result. We could just say, let's just add across the list. So you notice we put parentheses around the plus slash to say we're going to add across the list, and we're not going to specify an initial value. We're just going to start with the initial value in the list and then add across. There we go. Now, think about this for a second. Can it be any easier? Could you write less symbols in a program to add across the list? And the answer is, not really. This is how we add across a list in Q. But there are other things we can do as well. For example, suppose we wanted to multiply across the list. So star is multiplying Q. Let's make a list, oh, I don't know, 1, 2, 3, 4, 5. Now we've said multiply across the list, starting with the first item in the list, and continue until you're done. But wait a minute. What if we just replace 1, 2, 3, 4, 5 by the equivalent 1 plus till 5? Anybody recognize that? It's factorial, right? 5 factorial is 1 plus till 5. Generate the numbers 1 through 5 and multiply them. You have to be careful. Factorial grows very quickly, so you can run out of space in integer land. But there you go. There's 10 factorial. Can it be any easier? I don't think so. Look, Ma, no loops. Okay, so let's show a couple more Q operators to see other things that we can do with this construct. There's a pair. This is read style in a lot of programming language. 4 bar style 5. This operator is dyadic. It has two operands, and it returns the largest of the two operands. So in this case, 5 is larger than 4. On the other hand, if we did it in the reverse order, it returns 10. All right, so this returns the larger of its operands, and we can do the same thing with ampersand, return the lesser of the two operands. So the lesser of 10 and 2 is 2. The lesser of 4 and 5 is 4. All right, with me? All right, so now what can we do with this? Oh, well, lots. Suppose we have a list, 10, 30, 20, 50, 40, right? What if we did style over, or pipe, or however you want to read that. I'll put a space so you can read it, but it's not necessary. This says iterate the operation that chooses the greater of the two operands across the list. So what is this in abbreviated terminology? Max. This is the maximum of the list. If we did the same thing with ampere, which chooses the lesser of the two operands, we did that across the list, it finds the min of the list. Now, for some of these operations that have these funky symbols like ampere and slash, we have a modified way of writing this in Q. I like to call it Q for managers, because they really don't know anything. So we can say sum, which is really just plus slash in parentheses. We can say min. We can say max. Those are just manager-friendly names for the things that we've already done. All right? So you're beginning to see how easy it is to do operations on lists in Q. What else can we do? Well, I should tell you before I go on, if you think carefully about this, if you use pipe or style or whatever we want to call it with Booleans, that actually is OR. The larger of 0 and 1 is the same thing as OR. And ampere is AND. So closely related to the function over that we just described, or slash, is a close cousin called scan. So we saw that if we took a list and we added over the list, we get the final result. If we replace the forward slash with a backslash, it does the same thing, but it keeps all of the intermediate results. So now we see the running sum, if you will, 10, 10 plus 20, 10 plus 20 plus 30, et cetera, et cetera. We can do the same thing with our amperes and our pipes. We could say, show me the running minimum. Right, there's the running minimum, and here's the running maximum. And so we have names for those also. The running sum is called sums in Q. And the running minimum is called mins. And the running maximum is called maxes. So again, these will be useful later. Notice that we don't have to write any stinking loops.